what are the research challenges in getting vaccine to market quickly? What happens if it's too fast? And that's a good combo question there, because speed is good, but speed can sometimes be bad. Research is complicated because research isn't just doing your best guess, which is in absence of research and evidence base, what providers have to do. And in many instances right now, they're doing the best they can with the limited knowledge that they have. But research is the very formal study of data relating to a certain question. And it's really asking that question before you collect the data. So you're minimizing the bias of how you collect the data. You're minimizing the bias of answering your own question. And to do that with vaccines, a vaccine is usually created, oftentimes in an animal model, oftentimes in the lab before it's ever used clinically. When that vaccine is created, it's usually thought to work by some mechanism that makes sense. There's usually a face validity to it. It attaches to cells in this way that we know and we understand, so it could attack this virus in this fashion. But the problem is, you don't know until you try it, because there's always unknown variables. So there's actually a very structured series of trials that you need to do for clinical trials. Early on, you need to make sure it's safe and effective, or safe in humans. So you go through the phases of clinical trials, and you can get more detail on what those are, but you go through the phases of clinical trials to make sure it's safe, to understand what the dosage would be, and then to start to see if it's effective at solving the problem. The challenge is, if you move too quickly, you might use something that kills people, injures people, doesn't work, and uses up resources. And all of those are a danger if you move too fast. So you have to basically structure these trials to get sufficient evidence to feel comfortable moving to the next level, and then eventually moving to the level that we've got evidence to put this into practice. Normally, that's a very, very slow process. And when I say slow, when I wrote about it in the book, it's a 17-year from idea to putting it into clinical practice on average time frame. 17 years, iterative trials going through animal models or cell culture models, moving all the way to humans, and then a number of trials to get sufficient evidence. We want to move faster here, and a lot of times they're picking things that already have some foundation or basis. SARS in 2003 and 2004 had a very similar genetic makeup. So a lot of the groups that were attacking that problem are looking to some of the solutions that they used for vaccines for this latest SARS-2, as they call it. But it still takes time. And if you move too quickly, you waste resources, or you injure people, or you can kill people. If you move too slowly, though, it takes forever. So accelerating those trials, both at the administrative level, at the data sharing level, at the data collection level, to make sure that you've got good, clean data, and you can have the provenance to merge data sets from multiple trials when appropriate. All of those things are target areas for new approaches and new technologies that can speed stuff up. And obviously, blockchain is one of those.